What's going on, everybody? In this video, I'm going to talk even more about complex numbers and kind of put together everything that we learned about the operations of complex numbers and do a little bit harder problems. So let's say that I had 4 over 2 minus 3i, and I wanted to add that to the number 2 over 1 plus I. Just like that. So what I'm going to do is I'm going to use the trick of the conjugates and apply it to both the fractions. So I've got 4 over 2 minus 3i multiplied by the conjugate of this denominator, which is 2 plus 3i over 2 plus 3i. And I'm adding that to the second fraction. That's multiplied by its conjugate. So I have 1 minus I on the bottom and 1 minus I on the top. So when we do that, what we end up with is 4 times 2 plus 3i divided by 2 minus 3i times 2 plus 3i for the first fraction, and then I add that to 2 times 1 minus I on the top, and 1 plus I times 1 minus I on the bottom. And so distributing on the top and foiling on each of the bottoms of the fractions, this is what I end up getting. So I have an 8 plus 12i on top, and on the bottom I end up with 4 plus 9. And on the second fraction I have a 2 minus 2i, and on the bottom I have a 1 plus 1. And so what this gives me is I have 8 plus 12i over 13. And I'm adding that to 2 minus 2i over 2. And I can split up this fraction. I can split up both of these fractions. So I have 8 over 13 plus 12 over 13i plus 2 over 2, which is just 1, minus 2 over 2i. And so this just becomes an addition problem. So the way you do this is by grouping the real terms together and then the complex terms together. So I've got 8 over 13 plus 1 plus 12 over 13 minus 1 times I. And when I simplify this, I end up getting 21 over 13 plus or minus 1 over 13 times I. And this answer is in the form that we want of a plus bi. Okay, so let's do another one like that. Let's say that I had 1 over 2 plus I, and I wanted to subtract it from 5 over 1 plus 4i. This looks kind of bad. That's an I. Just pretend like that's an I. So what I'm going to do is I'm going to multiply each fraction by the conjugate of its denominator on top and bottom. So I'm going to have 1, 2 plus I multiplied by 2 minus I over 2 minus I. And then subtract that from 5 over 1 plus 4i times 1 minus 4i over 1 minus 4i. And what I get is I'm going to have 2 minus I on the top of the first fraction, and on the bottom I have 2 plus I times 2 minus I. And for the second fraction I have 5 times 1 minus 4i over 1 plus 4i and 1 minus 4i on the bottom. So I can simplify each of these fractions. On the top of the first one, it stays the same. But on the bottom, I have a 4 plus 1. And then on the second fraction, I've got a 5 minus 20i on the top. And on the bottom, I have a 1 plus 16. And so what this gives me is I have 2 minus I over 5 minus 5i, or 5 minus 20i divided by 17. And so what I need to do is I need to find a common denominator so that I can combine these fractions together. So I do that by multiplying the two denominators together, which is going to give me an 85 on the bottom, and then I cross multiply to find the top terms. So I have 17 times 2 minus I, and I'm subtracting that from 5 times 5 minus 20i. Then distributing what I have on the top, I have a 34 minus 17i minus 25 plus 100i, all over 85. So if I group the real terms together and the complex terms together, I end up getting 34 minus 25 plus 100 minus 17 times I, all over 85. And this gives me 9 plus 83 over 85. And then the last thing I need to do is split this up into two fractions so that I get the real part, A, added to the complex part, BI. And so this is going to give me 9 over 85 plus 83 over 85 times I. So I hope this video was helpful about combining all of the methods that we know to combine complex numbers together. Utilize the like terms and the rules that we have for dividing, such as dividing or multiplying each fraction by the conjugate of the denominator, and then you can do lots of algebra to rearrange it into the form that we want and fully simplify it. So I hope this video was helpful in learning how to manipulate complex numbers. I'll see you guys for the next video.